What if I told you that while human scientists spent half a century and billions of dollars developing treatments that barely work, an AI just created the first ever medicine from scratch in only 30 months? And this isn't a movie plot. Real patients with a deadly lung disease are breathing easier right now because of it. Let's put this into perspective. The disease is called Idiopathic Pulmonary Fibrosis, or IPF. It's a nightmare. Your lungs literally form scars from the inside out until you can't breathe. Most patients are gone within 3 to 5 years of diagnosis. It affects as many people as stomach cancer, but for 50 years, the brightest minds in medicine have been stumped. We have only 2 drugs that just slightly slow the disease. They don't reverse it, they don't cure it, they just delay the inevitable. Until now. Scientists at In Silico Medicine did something that has never been done before. They took their AI system, called PandaOmics, and fed it a colossal amount of biological data. Millions of data points on proteins, genes, and disease patterns. Then they gave it a simple prompt: find us a new way to treat lung fibrosis. The AI sifted through thousands of proteins and identified one called TNIK. Now, here is the truly staggering part. No human researcher had ever considered this protein as a target for lung disease.
Not once in 5 decades of research. The AI essentially said, "Trust me, this is the one." Then it got even crazier. The exact same AI designed the actual drug molecule to attack TNIK. No human chemist sketched this out. The AI generated it, optimized it at a molecular level, and predicted it would work. But in the process, they stumbled upon something nobody expected. When they analyzed the blood of patients taking the new drug, rentosertib, they found it wasn't just treating lung fibrosis. It was actually reversing multiple markers of aging throughout the body. Proteins tied to inflammation dropped, markers of tissue scarring decreased everywhere. Even proteins linked to other age-related diseases showed improvement. The AI had accidentally found something much bigger. TNIK appears to be a master regulator of aging itself. This means rentosertib might not just save IPF patients. It could potentially treat fibrosis in the lungs, liver, kidneys, and heart all at once. The AI saw connections that would have taken humans decades more to discover, if ever. From a computer screen to human trials in just 30 months, that's up to 10 times faster than traditional drug development. The drug was tested on patients whose lungs were actively failing.
The results? Patients on the highest dose of the AI drug saw their lung capacity improve by 98 milliliters. Patients on the placebo declined by 20. That's a 118 milliliter difference, literally the difference between taking a deeper breath and gasping for air. But what's truly revolutionary is this: the AI didn't just slow the disease. In some patients, it actually reversed lung damage. Their lung function got better. This has never happened before in the history of IPF treatment. This isn't just about one drug or one disease. This is the first time in history that an AI has discovered both the target and designed the drug that made it to successful human trials. We are talking about a complete paradigm shift. Diseases that have baffled researchers for generations, cancer, Alzheimer's, rare genetic disorders, could all be next. The AI can see patterns in our own biology that the human mind simply can't process. We're witnessing the dawn of a new era. While the old model takes 15 years and $3 billion to produce a single drug, an AI just did it in 2.5. This isn't science fiction anymore. The age of AI medicine has officially begun.